Good afternoon. It's quite interesting, the title of this session, Other Offshore Business Opportunities. And as you know, the ocean, the sea, the deep blue is a world. And I think that it is going to take quite a few years before we can take all the opportunities that the sea that can give to us. And this afternoon, in the WavEC annual seminar, we are going to listen to 6 opinions, 6 ideas, 6 business opportunities. Some similar, some very different, but I hope this will excite our minds to put them to work and find an opportunity for us. The first one is Gareth Davies, Managing Director of Aquatera, and he's going to talk about the realities of marine energy markets in the near, medium and long-term future. Gareth, you have 15 minutes. I will give you a warning when 1 minute is last, and after going to the next speaker, you have opportunity to make at least one question.
Okay, I'll start quickly to make sure I use my 15 minutes. So we're here for a particular reason. Basically, we're trying to save the Earth. It's no big problem. And the question is, where and how can marine energy help? And some of you may be here to find the answer to that question. Some of us have been working for a long time to try and answer that question, and I don't think we've quite got there yet. But what we're trying to do is find out where and how marine energy can best help the challenge of decarbonisation. So what we have to do is think about where in the energy mix marine energy can make a contribution. And this diagram shows the use of energy in the world, and what we're trying to do is identify where on the production and the use side and how marine energy can make a contribution. So there's actually many ways in which we use energy, and you can see them listed here on the left-hand side. And these uses of energy manifest themselves in many different locations, different types of locations. Locations with different types of infrastructure, locations with different economic standards and different economic levels. And so from a marine energy point of view, we need to understand these markets and these situations to be able to think very carefully about where wave energy and indeed other marine energies can best make a contribution. So there's a range of products, if you like, that as a sector we offer. And we've talked quite a lot today about the technologies, but it's not just about the technologies, because the marine energy technologies, the wave devices, are part of integrated energy systems that deliver projects. So we can sell energy projects to people around the world. Yes, we can also sell the generation technologies. But those generation technologies also rely on other technologies to enable them to work, and subcomponents that themselves can become viable products. So we can think about those subsystems as well as being markets. And it's not just about metal, it's also about people. It's about the expertise and the services that we can also sell. So as a sector, when we're thinking about the future of this sector, we need to think about these 4 product lines that can be perhaps exported and put in place around the world. So if you think back to that energy diagram, the Sankey diagram, each country in the world actually has its own Sankey diagram. The energy use in Portugal is actually not exactly the same as it is in Spain. It's certainly not the same as it is in the UK, and it's certainly not the same as it is in Indonesia, Singapore, the Philippines. So each country has its unique circumstances, and we need to think about where marine energy fits into those circumstances. And even on a regional basis, there's then sub-energy systems that provide a market opportunity. So there's in fact thousands of opportunities, thousands of specific opportunities that we need to think about delivering our services and our technologies to. Now, one of the ways that we do that is to look at where the resources are. And this map shows the results of an exercise that Aquatera has done to try and identify where tidal resources are in the world. And we found 14,000 references to tidal speeds, which we've collated into a database. And I know we've talked a lot about wave energy, but it's interesting to reflect on the challenge and the opportunity that tidal energy presents. And out of those 14,000 sites, there's only 600 of those sites which have a speed above 6 knots, which is where many of the tidal technologies are geared to. If you're actually targeting speeds of less than 3 knots, there's over 7,000 sites available. And there are specific technologies that are looking to that opportunity as well. So if we look at the tidal sphere, we can see already how the market can differentiate on the basis of speed between different market opportunities. If we go on to think about wave energy is not ubiquitous around the world. There are different types of waves and different levels of waves and different types of market that we need to think about. And so when we think about our technology, we think about our service, we need to focus on where it can be best applied. So the key question is, where is there a role for marine energy? When is that role? How are we going to achieve it? What is that role? Who's going to do it? And at what price? And that price question is really important because in the early stages of wave energy and indeed marine energy, we were absolutely focused on grid-connected electricity as the market. And that is the lowest price of energy that you can find in the world. That's the rock bottom marketplace. And looking back, we can maybe say it perhaps wasn't sensible for us as a sector, where we were working in the sea, developing new technology, to go for the bottom price as our initial market. But there are many other energy markets in the world that have a much higher value. And what we need to do is perhaps seek out those markets and focus on them. So what we've also done in Aquatera is try to develop a scheme to think about markets in different ways. And so this table lays out across the top. So across the top is the different types of market, and down the side it indicates some of the characteristics that may characterize those markets. And basically we start at small scale but high value markets on the left hand side, and then we move across to the grid connected large size low value markets on the right hand side. And you won't have a chance to read all of these parameters, but these parameters describe the kind of characteristics each of those markets have. Now we also have a set of technologies that have different scales and different price points. And here we've got the technologies listed down the left-hand side and some of the parameters that they may be needing across the top. And what we've done is we've combined those into a diagram here, which basically combines technology and markets and shows what we believe to be the range of opportunities that there are in the marine energy sector for different types of technology. And if we focus on that top corner, we think we can identify 3 zones. And my task today was to talk about short, medium, and long-term opportunities for marine energy. So we see the shortest term opportunities for market-based deployments being on the left-hand side, in those higher value market areas where people are already paying enough for their energy that they would be happy to accept wave energy. We don't need a subsidy or interventions. As you move across to the right-hand side, these are markets where the energy prices are quite low. You might need some support to get in to those markets, and we see those as more medium and longer-term opportunities for the sector. Now, it doesn't mean that the large technologies can't have a role now. We need to follow these many strands and develop as quickly as possible, but we believe that's a reality that is associated with the market situation at the moment. So the other part of this story is that in each of these markets, we have, in each location, in each scale of market, we have different conditions. And it's been often said on platforms like this that there's going to be one technology that wins. And my belief is that that's wrong. I don't think we're going to have convergence to one technology. And the reason for that is that the sea is an infinitely variable place. It has many different characteristics, and some of them are laid out here. So what we need to think about, not only the sea, but also the markets, the variety of markets that are available, we need to get the best fit for a particular technology into a particular market. And we also need to think, when we go to an energy customer, in essence, they don't mind whether their energy comes from wave, tide, wind, solar, whatever. They just need energy. So what we need to do is deliver energy to people in the right package for them to use it. So that means that as well as thinking about generation, we may also need to think about balancing and storage mechanisms. It may be that in the world market for energy, it's not possible just to sell wave energy devices and tidal energy devices or even wind turbines. In the future, we may need to sell those devices with storage or balancing mechanisms. And so this diagram shows the range of storage mechanisms that are typically available. And it highlights at the top in yellow an issue that we have is that many of the existing storage mechanisms are suited to short-time variability, and we probably need a longer-term mechanism to adopt. The other question in terms of what is where in the system from generation to use are we going to apply this storage and balancing mechanism? So in Orkney, the islands where I live in the north of Scotland, we've been exploring, before I go on to that, the other point is that if we're going to store and balance energy, we need to think about other energy sources that might complement us. So we sometimes see ourselves in competition with wind and solar, but maybe we need to think about those as additional tools in the toolbox to deliver integrated energy systems. So this is something that we've been thinking about in Orkney, and in the Orkney Islands, we've now adopted a hydrogen-based balancing and storage mechanism which links wind and tidal production up in the island of Edi in the north with uses for energy in Kirkwall in the south. And this is a pilot-scale project, or it's actually a number of pilot-scale projects, and it's helping us demonstrate that we can deliver integrated energy systems that support the actual energy needs of our customers in the islands. So as we look forward then, I think we need to reflect on how the world will change in the future. We need not to look back and see how the world adapted to energy issues in the past, because the past is gone and it's not going to be repeated. We need to look to the future and think about what is our role for marine energy, for wave energy, for tidal energy, for offshore wind in tomorrow's world. And these are some of the issues that we need to think about. It's going to be very different in the next 10 and 20 years than it's been in the last 10 or 20 years. And so we need to think about where this change is going to happen. Where should we be focused? And this diagram shows a picture of energy demand through to 2040. And it shows very clearly where the rising energy demand lies. But that doesn't mean that the red areas are not of interest, because in these areas, although the demand may not increase, what we have to do is decarbonize that existing use. So the whole world is a marketplace, and the future starts now. So we need to decide which market segments are we chasing and what are the delivered products and services that we're trying to achieve. So in conclusion, we see this as an optimization process. There are energy markets out there which have a high value, and if we target them with the right technologies, we can provide solutions today which satisfy those needs. We need to think about technologies that are appropriate for these market opportunities, and we need to appreciate that different technologies may take different pathways. This isn't a one-fits-all solution. And so the competition will not be between one wave device and another wave device, one tide device and another tide device. In essence, our competition is with other forms of energy that people have the choice to buy. Thank you.
Thank you. Thank you very much, Gareth. You didn't come here to listen to me, you came to listen to our speakers. Now I'll give the floor to Paulo Serra Lopes, Director of Ocean Motion, and he's going to talk about challenge of offshore aquaculture in the Azores. Paulo?
Good afternoon. Well, I'm going to present you a case that is now undergoing, is not finished, and it's basically a challenge which is to have offshore aquaculture in the Azores. As you know, the Azores Islands are very important for us because they represent a great potential on the offshore for a lot of reasons. Aquaculture now is still some people doubt about aquaculture. There is nothing to doubt about because we cannot live without aquaculture. You have here a kind of presentation of the produced and imported and exported fish products, and you see Europe is going through a major deficit. We don't have fish enough. We must produce this fish, and it cannot be otherwise except with aquaculture. You see the trend is growing tremendously, and from 2016 on, aquaculture already goes over the fisheries. You have to separate which is the fish for human consumption. There are fishes for industrial uses that may unbalance a little bit this comparison, but this is what matters to us. Aquaculture is vital, must grow, and must go wherever it's needed, eventually offshore. Now, we are in Portugal, and Portugal has a very specific feature. We not only have a high deficit of our production of fish, but we are also one of the biggest consumers in the world. We are the biggest in Europe and probably the third in the world. This makes our need for fish tremendously high, and we have also some very interesting feature. We are willing to pay a lot for our fish, which is not the case. We have the highest price for fish in Europe. So being eventually a less developed country in European Union, we still have the capacity to pay more for fish. That's why this market is so interesting. Also, you have to be clear about the future. The fisheries are not sustainable at all. You have heard this many times, but now the future will represent a tremendous challenge, not only on the sustainable of fisheries, but also on the fish species we are using. Because, as you know, we are dependent on three major species in Europe, especially Southern Europe. Salmon that comes from the Northern Europe, and sea bream, you are seeing here in this photo, and sea bass. Those two species, if they have any problem, 30% of the supply of fish in Europe goes bankrupt. And this is a major challenge, which is why European Union launched this Diversify project. We want new species for European aquaculture so that we can replace both the salmon, the sea bass, sea bream, and all the present species. They have selected 6 species. One of them is for fresh water, the other 5 are for marine water. In all those species, we have selected the greater hammerjack, that I will call now on Seriola. This is the scientific name, Seriola dumerilii, and it's in fact one of the best species ever experienced in aquaculture. Actually, it's already told as the salmon of the Southern Europe. This is our Seriola, and our challenge was to go to the Azores, overcome the very bad sea conditions, and still produce this fish in our offshore conditions. We have chosen between these 2 species exist in the Azores. The upper one is the one we chose because it had the sustainable support from Diversify. It's very important to have scientific programs going with you when you try new species and new environments. You must be aware that it makes a lot of difference to have scientists working on your behalf instead of going another vision of our Seriola. Well, the Azores. We were invited by the authorities to go there and to start a project in the Azores. We thought that it would be ideal to start in several places, but we should start the fish cage, the fish project in one place. We have chosen the island of São Miguel, the capital, the bigger one, and in fact, very nice. But the good of the Azores is not what is inland, which is absolutely gorgeous, but that's not what we fear. We have incorporated this new company to cope with all the challenges of having fish farming of Seriola in the Azores. And in the island of São Miguel, we have chosen the place of Ribeira Quente, where we installed our concession. Bigger challenges were to come because what we thought it was easy to do, it's not. This is very near the coastline. That's another advantage of the Azores. We went to Panama to see exactly the same methodology and technology of farm, and the farm we visit in Panama to have the depths we have here in the Azores at 500 meters from the coastline. In Panama, they were 12 kilometers from the coastline. That's our advantage, to go deep, very, very close to the land. And so there are some good things and some bad things. Waves are the bad things, you'll see in a moment. This is what looks like when Azores Sea gets furious, and it's really not a good sight. Unhappily, we should deal with it because our goal is to be offshore and to be competitive there. As you can see by this image, the waves go very, very, very little effect on the waves on depth. So we must go deep, and that's the only advice offshore aquaculture can bring you. We have selected this cage because it's the only one in the market that can go to the bottom, can really go deep and can sustain all the conditions of fish farming being underwater. The only thing we cannot achieve with this cage, but it's another challenge for whoever wants to go along with us, is we must start feeding underwater, which we don't at present. We only feed at surface. We needed a silos or something else. Some developers are already bringing some projects, but still they are not ready to be able to have the fish underwater and give them the feed underwater. This is more or less the way the cage behaves. You can lower it, and any storm, any bad weather goes over it. We've experienced it already. We have already overcome 2 major storms with those feminine names you receive when they come from the United States. And we could get all the cage and all the moorings and everything was absolutely fine. This is just a vision of how the cage is used. We call this project Atlantic Fish because it was really an Atlantic challenge. I believe that the guys who sold us the cage still now, they don't believe in us. They think that we will handle the cage about in 1 year, and the second year it's gone with the sea. Maybe that's the case, but we still give it a try. And we are in a very deep area. In fact, one of the final points of the concession, the lease that we got from the government, according to the maps of NOAA and all the international and national entities like Hydrographic Institute, tell us that we were on the 70 meters depth. In fact, we had in that specific point 122 meters. It means an error of 50%. That's what happens when you don't know the sea you're working in. In fact, it's never too much to call your attention to the fact that the ocean has an average depth of 4 kilometers. We barely know 200 meters of these 4 kilometers depth. And that's the problem with any activity offshore. So some images, just to let you know how big is this cage. We are talking about 6,400 cubic meters, a 4 stories high building if you transform this. Huge means to tie it to the water. And in fact, offshore is like this. You cannot go soft. You have to have all the capacity and all the means. This cage was specially adopted and adapted to the conditions of Azores. We see here the cage being transported outside. We had to not only trust in the cage manufacturers, but also reinforce everything we could, because in fact, she will be presenting enormous challenges in the near future. The cage is already installed with a lot of very good details and very good expectation. The fishes will get into this cage next week. That's just perhaps, I hope that you will see the cage on the next months, because if you don't, that's a very bad indication. But just to give you a sense of size, this cage is like 25 meters high and 30 meters wide. And it can produce about 150 tons of fish. And in fact, this is where the fish is good, and where the fish should be at all times is in the deep. The best advice for offshore fish farming is going deep. And this is our major challenge now, is to be able to go deep and to be able to perform all the operations of a fish farm like this inside the water. And we have a very skilled and experienced diver team with us. And this is the only way to perform in offshore. Thank you very much.
Okay. So it's time to move to another speaker. Now I'll invite, take the floor, David Campbell, is CEO of Albatern, and is going to talk about providing power to offshore fish farms with sustainable wave energy. Paulo, you can use this system.
Thank you very much for the introduction, and thank you also to WavEC for the invitation to come along. And given that we've been working for some years in applying wave energy to aquaculture, this seems a very appropriate event for us. And in the picture that you see on the screen at the moment, you'll actually see this is a project that we carried out in 2014, where we were trialling our wave energy system in a site that was being developed for salmon, but before the fish arrived and the risk appeared. So the experience of aquaculture, and this picture is actually from Asia rather than from Europe, but it was a similar piece, that people started fairly close to shore with square cages, first of wood and then of metal, but found that in extreme conditions those cages would still suffer damage. By being close to shore, they were easy to operate, but there are challenges in that environment with disease, with biology, with sea lice, with the salmon in particular, and in Asia there is pollution close to shore. And from our point of view as a wave energy company, there's very little resource for us to work with. If we then look at how that matches where some of your salmon will come from, in Scotland, you'll see here, this is the active sites, and there are somewhere around 160 active salmon sites in Scotland at any point in time. And you'll see that all of those are relatively close to the coast. There are very few that are actually out in open water, as has just been described in the Azores. But if I zoom a little bit in here to the middle of Scotland, and this point here, which I can't show you, but the point of land that comes out is the most western point of the mainland. And you'll see here, if I move through, you'll see some sites, as I've just circled, that are still of the traditional sense close to the shore and in sea loss, where sea lice, freshwater, disease, if disease comes into one site, it will easily transfer to another. But Marine Harvest have actually developed some further sites that are far more exposed, and those are shown ringed there. So this move to more open water sites is underway in Scotland, it's underway in Norway, and I'll come back to that a little bit later. The salmon farmers like it because they get better fish growth. I'm not entirely sure that they fully understand that, but it seems from the analysis that we've done that it's a combination of more water movement, the wave energy, the current, encouraging the fish to swim better, but also to reoxygenate. And that means that the salmon are developing better gills, and that's encouraging them to grow better and faster. The move offshore has been enabled by different equipment. So rather than the first photograph I've showed you, this photograph here, although a bit blurry, is showing the round high-density polyethylene cages that have been shown to be more robust. And as those cages have been made larger in diameter, they are able to cope with stronger wave conditions further offshore. Although, as some of the recent experience around the Atlantic Islands over last winter has shown, when you couple the cage to the surface, you are exposing it to some very high loads, particularly when the waves are building up. Not so much current, which is what most of the mooring calculations so far have been dealt with. The open water, giving that better oxygenation, less issues with disease because you can space farms further apart. And from our point of view, the good news is that there's some commercially viable wave energy in those sites. If we're in sheltered water inshore, there's really not enough to harvest from. So the wave energy challenge then is how do we capture energy from this semi-chaotic or semi-organized chaos that is a wave climate? We've developed a system that is individual modules, which are easy to, or individual units, which are easy to deploy, and we couple those together into an array. And down in the bottom right, there is a video that shows some testing that we did in Ifremer in France in 2012, and that just illustrates how this space frame structure of 3 dimensions with links between the bottom of pillar buoys and floats on the surface is moved by the waves. And at each of the junctions, we've got hydraulic rams that capture the mechanical movement that's created by the waves and use that to drive a hydraulic motor, which drives a generator and produces the electricity. The advantages that we can see are that that structure will actually capture energy from waves of any dimension, so we don't need to align it within its mooring system. And also the performance of each unit is actually accentuated by the fact that it's responding not just to the waves, but to the units that are next door to it. So the first set of devices, we've taken a slightly different approach to many of the early stage devices, which were going straight for big scale, large scale devices and working in big seas. And we deliberately designed it so that it would fit onto the back of a lorry. And one of the things that attracted me to the company back in 2010 was that it seemed to be far more capital efficient to do our learning with smaller devices, which actually matches the trajectory of wind energy, which had some very big prototypes to begin with, but they tended to be abandoned. And it was the smaller devices that could learn about gearbox failures at £1,000 a gearbox rather than 50, 60,000 euros a gearbox. Secondly, we've been able to use the cranes that are already in sight, that these cranes that you see in the middle picture are normally used for shifting fish feed onto boats for distribution around the farms. And when I put some prices up there to move one of those devices from our workshop near Edinburgh, which is land-based, to a site up on the west coast of Scotland, it's costing us about 900 euros. To have a crane operation to lift it into the water, because we're not moving a crane from anywhere to do it, it was around 340 euros. And for all the boats that you'll see in a video just shortly that we're carrying out the mobilization or the deployment, we're actually using vessels that marine harvest provided for us, but that cost is about €4,500 a day rather than some of the more exotic rates that you see in other projects. And we've coupled that with a low-cost maintenance strategy so that we can carry out maintenance of parts with low mean time between failure by removing all the generating, everything from the hydraulics through the hydraulic motor, the generator, the SCADA, the control system. All of that fits into one module which lifts out of one of the floats, can be taken ashore. We can either drop another one in to replace it or take it back later. So why are aquaculture companies interested in blue power in Scotland? From our experience, there is a number of factors at play. One is if you're needing power on the site, then you need to generate it somehow, and that's traditionally been done with a diesel generator. It's reliable, it's a low cost to buy the capital equipment, it's reliable. But fuel costs are rising. They rose up to 2012, and I did have an old slide that missed out the bit where it dropped down again. But really, since 2015, we've seen diesel prices rising. And unless there are global events changing again, then those prices are likely to continue to rise for a number of reasons. But also, the farmers are keen to have a product that has got a green credential. So if they can show they're not having to use dirty diesel to produce the fish, we're actually seeing some of the supermarket chains giving our customer a higher rating for environmental consideration with a wave energy device on their site. And lastly, the blue power is available because we're into an environment where there is a wave climate that we can harvest. And just to give some context to that, this is a graph that gives some of those generation costs. The point has already been made that grid electricity is very cheap because it's produced in bulk in a very efficient way. And the cost level of that is down at the bottom right of the picture, which possibly you can't see very clearly because it's behind the seats. But in the Caribbean, which is another market we've looked at, it's a bit higher. On UK fish farms, where we have done quite a bit of work, it is higher again, and some places in Chile where it's extremely remote, the costs are even higher. So if you ask me which bar you want me to limbo dance under, I would rather be going under one that was higher rather than grid, which is about as low as it can get. So we carried out a project in 2012 through to 2015, a feasibility study, and we then had following 25 projects going through feasibility. We were one of 6 selected for demonstration, and that was completed in 2015. So we looked at a number of sites and also potential sites and looked at the wave climate and looked at how that wave climate would then translate into the power that we could generate from our device. And we were able to show that we would start getting feasible outputs where we could see waves starting to kick in at about 30 centimetres or 0.3 of a metre, significant wave height. If you look at Portugal and the area offshore into the Atlantic, the red bars, or they're very little red there, but going from dark blue on the scale at the left-hand side, there are some areas shaded by the islands where the wave height is relatively low. But there are others where you start going further north to the Azores where those wave climates get higher. This is a tool that we've developed that is using our device and its response to give different amounts of electricity yield as well. But I think the point has also been made that averages are very dangerous, and what we've got to be able to survive are the extremes. So we do need to understand the wave climate much better. We've also looked at how we can moor our array within close to fish farms. And again, risk has been the main problem here. We took 18 months to convince insurers and the fish farms that it was safe to put our device in the water. And we've now been deployed for just over 2 years with a 6-unit array that has still stayed put through 16 named storms. The site electrical load is interesting as well, because this is some work that we did in Chile with a university to look at the power load through the day. And from that, you'll see that when the fish feeding system, which is air blowers on the farms, is running, there's a very high amount of power. But as you average down, if you look at the average yield, then the amount of generation that you require to meet that spiky load is much lower. But that also says that we need some storage to handle the gaps between generation and demand. So we showed a map earlier, and there are two sites. The Isle of Muck in the north side of this diagram is where we carried out a test in 2014, and Mingery Bay, which is just a bit to the south of that, is where we are currently operating. And I'll just run a short video that, rather than me talking about what's involved in deploying a wave energy device, this video will give you some idea of what's involved. So within our workshop, we're working fairly easily with some fairly basic equipment to assemble the unit together. And then we head up through Glencoe in better weather than the Bond film saw. And we get to shore where we can then load this out using the cranes onto a multi-cat vessel in this case. And then we head off from there and head out to site in amongst offshore islands where, in fact, 4 of the 10 UK islands that are not grid connected are in the background in these pictures. So the first operation that is carried out is to lay the mooring system. And we're using 6 units, so we have a triangle formed of 1 unit and then 2 units and then 3 units. And that forms a triangle with a drag embedment anchor at each corner of the grid. And the units can then be dropped into the water, and you'll see the size of the boats. These were 5.5, 6 metre ribs that we were using to tow the unit into position. And then we changed the ballasting to drop the unit into the vertical operating orientation, and we then put air back into the central riser to bring the unit up into the normal position that it should be in for operation. And you'll see there the floats are moving apart, and you'll see the weight of these as the last one is lifted off. But I'm running short of time, so I'm going to cut through the rest of that video, just show a short section. This is video running in test in another Scottish loch, and you'll see the different parts of the structure responding to the waves. And each time there's a movement on a junction, we've got the hydraulic ram capturing that and sending it to electricity, and our cable ashore suspended from the pink buoys that you can see here. We then moved into, loaded 6 units onto a fish farm vessel and moved to our current site, where we've been working with support from Wave Energy Scotland and Marine Harvest to put in a structure that is over on the left-hand side of the screen here, with a cable to a shore station and then a cable taking us out to the feed barge here. This is partly to accommodate fishing in this area here, and also means that at this point we're only a kilometre from the grid connection point, so we have actually grid connected the project as well. Just a couple of illustrative examples here of different ways that you can couple the units together to give you a different output. And I'm going to round off now just by giving you some examples of where I believe that aquaculture is heading as we move offshore. The top 3 are the Ocean Farm 1, which was built by a Norwegian company, Salmar, and put into the sea in Norway, but built in China. And one of the challenges there was, how do you get that size of structure onto a boat halfway around the world? Because it was nearly 10 weeks late, because I can imagine with that protrusion over the side of the vessel, we were actually in quite an interesting way of moving things about, or the structure touching the water. But you'll see also the cage that the Azores have just been talking about, another cage from a similar company. This cage here is in build in China. It's been built now. It's for developing salmon in the Yellow Sea off the east coast of China, and is designed to sink and sit on these pontoons at the side of it. And there are probably another 7 or 8 different projects in China where they're looking at different forms of offshore structure that are heading towards spar-type structures and using those to mitigate the amount of wave energy that can interact with the structure. And our challenge, I think, is how can we continue to provide wave energy for these structures without lending or without becoming subject to the storms that come through. And with that, I would thank you very much for your attention and happy to take any short questions. And I realize I've run over my time, so thank you.
Thank you. Okay. Thank you. Thank you. Leave the microphone there. So now we are going to listen to Pedro Diniz, Director of Marismar. He's going to talk, show his experience of offshore fish farming in Madeira Island.
Okay, good afternoon. Thank you for the invitation to be here. I'm going to speak to you about offshore fish farming in Madeira Island. So, as most of you might know, Madeira Island is located off the coast of Africa. It's a small volcanic island with very transparent waters, oligotrophic waters, with big depth near the soils as well. So, aquaculture development in Madeira started in 1996 with an offshore fish farm project with the support of Stirling University from Scotland. And as everything went well, in 2002, there was constructed a research and development center with a hatchery as well to support the industry of aquaculture. In 2004, the first offshore fish farm, Ilha Peixe, started working on the site of the fish project. Then there was a second offshore fish farm in 2006, and last year, Marismar, where I currently work, started operating. So this is the location of a fish farm pilot. So it's in a bay on the southeast side of the island, quite protected. They tested two equipments, farm ocean, so the big one with 3,500 cubic meters, and 4 small high-density polyethylene cages. So the normal average cages we currently work with. This is the location of the current 3 companies working in Madeira. So the farm ocean was deactivated due to high management and high maintenance work. And so currently we only work with a regular circular polyethylene cages. So this species has been grown in the 3 offshore companies. Sea bream. One of the companies is also doing Seriola, not in an industrial way yet, due to development of the species, but already working on alternative species for aquaculture. So this were the sales of the sea bream from the first years, basically in the local market, and then from 2008 onwards, basically for Portugal mainland. In Madeira, currently, we have a hatchery, but for small production. Ongoing growth, we have the harvest, and then we have the packing and commercialization of the fish. So specifically in my company's project, Marismar, we currently have 6 batches of fish per year, origin France, Spain, and local from the Centro de Maricultura de Quilheta. The fish come in juveniles with 4 grams, normally around 300 fish, so a total biomass of 1,200 kilos. Average time of growth is 12 months until we have reached around 330 grams. So that's the commercial objective. And then we sell the production on a fish over 200 grams. Different grades, 200 to 300 grams, 300 to 400, 400, 600, and over 600 grams. Normally, each cage will have a total biomass of 90 tons, around 270,000 fish. Annual production is 500 tons. Main client is a major supermarket chain, Portugal, Pingo. So I'll just go through some operations that we currently have at the site. So first I'll start with hatchery and batch inspection. So before we take in the juveniles, we go out to the hatcheries and have a look at the hatcheries, see quality, see biosecurity, see the batch we're going to buy, see if everything's okay. So there's an inspection of the site. Here we were testing different mesh nets, depending on the size of the fish, to be sure that when we receive the fish, we're not going to lose fish because of the net, wrong net size. See, we tested the fish, mean weights and other biological parameters. The reception of the fish is done through, we take a small cage to land into the port. We fit the net inside the cage, and then there comes a truck with a fish from local hatchery or from France or Spain through shipping, and then each tank is opened and the fish come inside the cage. Then the feeding. The feeding comes from Portugal mainland and Spain currently. The 25 kilo bags, different pellet size depending on the size of the fish. And this is just a small video of the current feeding activity. They're thrown into the center of the cage, and as the fish swim, feed is distributed. Okay, some of the activities we have fish transfer, because normally the fish go into the smaller cages, and then when they're around 300 grams, 30 grams, we transfer it to the bigger cages. So from the small cages are 12 meter diameters to 25 meter diameters, and you loosen the mooring system, the small cage. You get the small cage next to the big one. You get a channel, and then you get the fish from one side to the other. So yeah. All of this needs a highly trained team and people that are used to working in fisheries. They are very careful so that the nets are well close one to another, and you don't lose fish on the transfer and all other activities. Then you have the harvesting. So you have a boat with a crane. You get the fish around PSC net, and then you capture the fish. We now have a boat with a crane. This was before we had the boat with a crane. It was quite hard work. And then the fish come into the big boxes, water and ice. We add some more ice before it's transported to be packed. So this is in a factory. The fish is quality control for temperature. This is critical if you want to have a product with quality when it arrives on the market. This is a selection of fish. All the fish that have got problems, back problems or other problems, are put away, and normally they will be filleted for local market. different grade of fish. This is how it ends up in 6 kilo boxes. Pallet is made into a container, and then off it goes to mainland Portugal. All the information is kept. This is very rigorous traceability information with everything that is needed. Just short information. This is the Aquanetics. This is a program we use to manage our aquaculture units. So we've got all the different cages. We know exactly how many individuals are in each cage, mean weight, biomass, densities, we have the mortalities, we have a FSR. So this is very important in order to manage the growth and of the project and growth of the fish. So in terms of infrastructure, we've got currently 10 cages, 4 with 12-meter diameter, 6 with 25. Depth inside the cages are from a minimum of 3 meters when you arrive the fish until a maximum of 10 meters and 20 meters in the bottom of the cage. Because when you do not have any currents, the cage, the bottom will go to further depth than 10, so normally it's 20 meters. Depth of the seabed under the cages around 40 to 45 meters. This is just see how they're actually placed. You have the big cages, and this is just have information. The cages are not anchored to the bottom directly. They've got a mooring until the buoys and until a ring, and then the ring then takes mooring until the anchor. So this is a net. That's the bottom of the net, and it's cut sideways. Of course, as exposed side, we have rough weather, very rough weather as well. This year, in first days of March, we had waves over 10 meters. So it was a big storm. Luckily, everything went well. Small cages broke. Luckily, we had no fish in the small cages. This is another problem we had. There's a buoy that the mooring was not sufficiently strong. So what we have a lot of work of maintenance with the divers. These are holes. Every three times a week we dive because of the holes on the nets. This can happen because of the sea bream will try and eat the nets, or other big fish around the farm might try and get in, or just because of the stress of the equipment. So these are the weights on the bottom of fish farm. These are the rings. They have all the moorings from different cages. This is substituting some of the moorings. Okay, everything went right. This is inspection. So I had a team over from Scotland, from Cames, to do the inspection of the rings and of the buoys. This is crucial, so that when we have bad weather, we've got everything organized. Okay, future of aquaculture in Madeira. Our company will double production capacity from 500 to 1,000 tons a year next year. We'll have from 10 to 20 cages. There's one new offshore fish farm under licensing procedure. Eventually, we'll start producing this next year. There's a project of a commercial hatchery. Eventually, we'll start construction next year as well. And the total production expected in a few years is approximately 3,000 tons. Okay, thank you.
You have to move on because we are already behind schedule. Pedro, Pedro Pires is a guy from home. He's the head of technology of WavEC, and he's taking about his work on path in aquaculture sector.
I know. I'll try to make it quick.
What decision of the organizer?
Okay, I'll try to make it quick then. Okay, so WavEC, in terms of aquaculture, we started in 2016. And the objective of WavEC, by entering in aquaculture, was to transfer all our know-how and technology from other fields such as marine energy renewables to aquaculture. And with that in mind, we could provide several services or even projects that covers almost all the value chain on the pre-feed analysis, go from engineering, instrumentation, planning tools for operation and maintenance strategies, and even environmental and socioeconomic impact assessment analysis. So when did it start? It started in 2016, I told you before, and it started with this project called Artifacts. Well, both Kraken and Artifacts, they were developed side by side. One, the Kraken one, was funded by Oceanic project, and the Artifacts is funded by the Innovation Norway. And the main objective of this project is to develop a tool that you can use and attach to a small ROV and use it as if it was your own hand working underneath on the subsea. This gap that we identified is because, as you've seen before, usually, especially in aquaculture, you use divers to do all the repair and maintenance, and that comes with a risk. That's why you use divers, because, well, they are cheaper than world-class ROVs, because they are big, they require big vessels. So there is a gap there that we could fill with some technology, and we could reduce the risk and reduce the cost of operation. This technology came from the surgical sector, where you can use telemanipulation and operate a robotic arm on the subsea or on the surgical room as if it was your own hand. Wouldn't it be cool that you could have a device that could read your hand motion and you can replicate that motion on the subsea? So that's all about Kraken and Artifacts. We are going to use a device that will read the user's hand motion and replicate on the small ROV, and you can make knots underwater. So you can repair the fish nets easily. We are not doing this alone. We are working with IST in Portugal, with Oceanic in Gran Canaria, and CADFEM from Ireland. This is in Kraken. With Artifacts, we are working with big companies on aquaculture. Besides that, this was the kickstart. After this, we started to have more and more R&D projects working on WavEC. One of those started this year. It's called Blue Cow. We are working with Kimana, that already presented the presentation this morning, IST as well, Cecil, and aquaculture called Rota Grega, that will install the aquaculture in Olhão, in the south of Portugal. Basically, this project will design a support structure based on an oscillating water column that will provide energy and also act as a reservoir for feed the aquaculture system. We also started doing services during the past year. We started by doing a study of off-grid energy production for an aquaculture in the south of Portugal. We did everything from scratch. Basically, we asked the client what were going to be their control strategies for the energy production or the energy consumption, and what will be the requirements biological-wise in terms of oxygen and feed. We then defined the loads based on tides and detection and so on, and then we optimized what would be the best energy production systems that could support that aquaculture. This was all integrated with energy storage, diesel generation for backup, of course, and with floating solar, because we had some floating, with some channels that we could use floating solar devices to support the energy production. In the end, we delivered the investment plan for the energy production for that aquaculture system. In-house, we also have a lot of expertise in CFD. This creates really cool pictures, as you can see here. We worked with several companies, all of them Norwegian, for the offshore, well-known offshore aquaculture system that are developing over there. The one I can show you is this one. We did this work for Global Maritime, where they wanted to optimize the internal flow to recirculate the best we can the oxygen and release the debris that could get stuck in the aquaculture system. So, because you can see, there was a lot of motion inside the aquaculture system. We are also doing right now a service to Jerónimo Martins to do a site selection for them. We are doing this based on the site characteristics, so we identified several possible sites regarding its water temperature, waves, current, bathymetry, and soil. We did the biological evaluation for different species and for that different locations. And we also analyzed the logistics between those sites and ports, nearby ports. In the end, will deliver a map, as you can see here, where you can clearly identify the red are the less suitable, the greener are the most suitable. It's not this map, of course. We're not going to present you the end result of a client. So what's our goal in WavEC in the near future? Of course, we want to support technology to go into market. So both in-house technology that are developing, Kraken, as I mentioned before. We'll do some tests in the wave basin later in 2019. We will also deploy in the first trimester of 2019 the Sea Scout system that's going to be, it's an autonomous monitoring system that will measure several multi-parameters from the water column. And we are also starting a biotechnical economic model. That's the new way of thinking, that instead of thinking, when should I start aquaculture production, think the other way around. When should I put the fish in the market, and go that point backwards. In the end, you have an eerie trend of the client needs or the market needs, and you'll give you when should you put the fish in the water. Taking into consideration the biological model, of course, of the fish, and the logistics and operation, such as availability to the site. Will have 24 hours, 7 days a week availability to the site. You'll take that into consideration, so that will also you cannot feed the fish every single day, so that will affect the growth rate of the fish time-wise. And of course, that can be updated in real time during the exploitation part of the project. In R&D, we would like to develop new tools. So continue to make cool graphics and cool pictures in CFD, but now taking into account the flexible structures, such as fishnets. So to understand better the loads of currents and waves when they are interacting with this flexible structure that we talked about on these presentations before me. Also test new anti-fouling paints. We're not going to produce paints, of course. We are good at testing them. And probably see those impacts of these new paints in aquaculture, even in the fish. And of course, digital twin. We are already doing that in wave energy, and we are also doing that for robotic arm that I showed you about before. One of the things that we would like to do, and we are working on that right now, is to have a digital twin of the robotic arm, and you are not going to operate the robotic arm, the real one, you're going to operate the digital twin. This what gives us is you don't need to have high bandwidth to control the robotic arm anymore. You can get small amount of data, you put that on digital twin, and that small amount of data, all of a sudden you have access to all the sensors, virtual sensors, that's down there. What this gives us is we don't need to have an umbilical to control the robotic arm anymore. It can be by radio frequency to the ROV, and then you have an umbilical. This is part of the Artifacts project that I told you about that we want to explore in the near future. No, 1 minute. It's my last slide. Okay. Finally, we would like to promote an offshore aquaculture pilot project here in Portugal. Of course, there are some that were presented today, but we want to have to be part of an open waters, exposed environment as in Azores, and support developers and investors in new species, in new technology exploitation. So how are we going to do that? We have a tremendous skilled personnel in our offices that can help you with all this and pushing the aquaculture to new boundaries. Thank you.
Thank you. Jorge Luzzi, Executive President for RCG Risk Consulting Group, is talking about risk managing the renewable sector.
Okay.
You also have 10 minutes. That's
yes, I'm lucky because it's already 3:30. That means anything that I talk is over the time. And by the way, it's nice to hear in the other presentations, I saw that David mentioned about the problem of risk and the needs of negotiation with the insurance reinsurance market. And when Pedro was talking about tools that could reduce the risk, eventually could be in favor of do a very good analysis or reduce the premium of the policies to cover eventually that kind of company. That means we are in front of something that normally affect us. When I start my career as a young boy, centuries ago, I was in contact with a boss that he was a teacher too, and he told me, you will be in a world of insurance, reinsurance, risk management. Nobody would like to hear about what you say, but all the people will need you to talk with you in some moment. And because you bring capacity, that means capital, money, to protect the investments of the others. And don't worry about this profession to finish, because the profession will never finish, because it's adapting since the first moment on to the new realities of ethics, business, people, religion, etc. And he mentioned to me two cases that I will say very quickly. One was Marco Polo and the trip to China, and the group of people that were working producing vessels, the people that was working in Venice to try to get spices to Europe, they create a kind of mutual of insurance paying 5%, 2% more than what the cost of the construction of a boat was necessary to protect the one that had the bad luck to find in Malaysia with Sandokan and the tigers. And if that happened, they have a little fund. That means a basic idea of insurance about this reality. Centuries after, Mr. Edward Lloyd in London, in his bar or coffee business, he realized that there were a lot of bets about if the vessel will come back to land or not. And he said, we can do a business of this. He had a lot of different activities inside his bar, and he includes a kind of betting, but also was the base of the future Lloyd's of London, generated in the imagination of this person, thinking in how to protect risk of the others. We are in front of new situations, and as I mentioned, all this business will be in a way related to the insurance, reinsurance, risk management business. In what way? In the way that the insurance and reinsurance do. The insurance and reinsurance help to develop and have a social responsibility to help to develop business of any kind. And if we see about all what we were talking today, We saw that we were talking about fishing, mining, etc. The idea of business related with energy is changing, but in a positive way. The first presentation was touching about that. The first presentation were touching about talking that subject. We are in front of a change that maybe will be living together of the traditional energy with the renewable energy. And most probably in 50 years, 60 years, or I don't know, the fossil energy will be out. And we are seeing that today the electricity is coming, for example, the automobile industry is moving from working with oil to work with electricity. It was almost the market asking for that. And you will see that eventually energy is coming from thermoelectric, from hydroelectric, and is moving and moving and moving to solar and to all the other kind of new clean ways to produce energy. What we will have, and to be quick, we will have the need to have more information. Why I say that? Lack of information in the insurance, reinsurance, risk management business mean higher prices and less capacity. Then less capacity means less appetite of the insurance market to take part of your risk by their own, because at the end, the insurance is a way of transfers of risk from one to another. For someone that is trying to do a new business or to do a business, and someone that is expert in to manage and to do an equilibrium with different kind of business that he take through the premiums. The new situation most probably will put us in front of the need of information. Why I say that? Because if you talk about the claim of Exxon Valdez in Alaska, or the claim of British Petroleum in the Gulf of Mexico, you will see that they have insurance capacity, they have provided by the market, they have captives that were a known way to manage captive insurance, a way to manage the business that they will be in front of. But when we go to the new kind of renewable energy, even is more clean, there is less information about what could happen with claims. Then, as I say before, the lack of information is higher price, less capacity. Then it's very much important to have a kind of contact between these renewable energies with the insurance market, because we are talking about to be allied, to do business, to do new business together. I will not, I don't have time to go in this big detail, but I will mention the best idea. We need to start with the process of to risk analysis, identification of risk analysis, after to do the risk analysis, to think in mitigations, and tools, as Pedro mentioned, are very important, because most probably this will help to reduce the potential impact of a claim, treatment of risk, and at the end, we have the transfer risk to the market. I will finish here, because if not, we will have so much time. Thank you very much, and I'm ready to answer questions.
Thank you, Jorge.